Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, we're talking about how to interpret chemical formulas. Here's what I'd like to accomplish in this webcast. I want to describe the information that's presented in chemical formulas and use this information to determine the number of each kind of atom present in a particular formula. We're going to do this by using subscripts and parentheses and coefficients. Chemists use chemical formulas as a shorthand way of telling us what the composition is of a substance, how many atoms of each type. All right, it shows the numbers and kinds of atoms in the smallest piece, a representative unit of that particular substance. We do this by using subscripts to show whole number ratios of the numbers and types of atoms, right, for each atom. Obviously, it's got to be whole numbers. You can't have half an atom. The subscripts have to be whole numbers. We can think about this actually as three simple rules that help guide us through the way chemical formulas are written. Rule number 1 says that we're going to use subscripts after the chemical symbol to indicate the number of each type of atom. So, for example, if we think about vitamin C, also known as ascorbic acid, one molecule of vitamin C has this formula. It means there are 6 carbon atoms in one molecule, 8 hydrogen atoms in one molecule of vitamin C, and 6 oxygen atoms in one molecule of vitamin C, for a total of 20 atoms in the molecule. One thing that I want to point out about this is that if the subscript is not written, it means that there's 1. So I don't have to write a subscript of 1. If it's not indicated, assume it's 1. So if I'm looking at the formula for sodium sulfate, which is given here, I'm saying there are 2 sodium atoms. We know that because it's got a subscript of 2. And there's 4 oxygen atoms. I know that because of the subscript 4. But the sulfur has no subscript written, which means it's 1, right? And so we don't want to forget that, obviously, that the sulfur atom is there and that there are a total of 7 atoms in one formula unit of sodium sulfate. Sometimes in a chemical formula, we want to show that there are multiple copies of a particular group of atoms. And so we will sometimes write atoms inside parentheses and put subscripts outside of them. And when we do that, the subscripts outside the parentheses apply to every atom inside the parentheses. This is often used with polyatomic ions, and that's what we've got an example of here. So we have magnesium hydroxide, all right? Notice that the O and the H are inside the parentheses, and there's a 2 outside the parentheses. What this is telling us is that there's 1 magnesium atom in this unit, all right? But the 2 applies to the O. All right, so there are 2 O atoms, and the 2 applies to the H as well. So there are 2 H atoms for a total of 5 atoms in one formula unit of magnesium hydroxide. And finally, sometimes we want to be able to show that there's more than one copy of a particular formula unit or molecule. And we can do that by using coefficients. So if we write a formula with a coefficient in front of it, it applies to everything in the formula. So I've got the compound ammonium sulfate here. So you'll notice the N and the H's are inside the parentheses, and there's a subscript 2 that applies to the N and the H atoms. Then there's the sulfur, and then there's 4 oxygens. But I've got 3 copies of this, so the 3 goes to everything here. So what I'm saying is that I've got 2 nitrogen atoms in 1 copy of this formula, but since I have 3 copies of the formula, I have 6 nitrogen atoms total. The 2 also applies to the H's, so there are 8 H's in 1 copy of the formula. But I've got 3 copies, so there's 24 H atoms. And then I've got the 1 sulfur atom in each copy, so 3 copies, so 3 sulfur atoms, and then a total of 12 oxygen atoms as well. All right, so we can indicate that there's multiple copies of things by putting the coefficient in. Now, if there's no coefficient, I don't have to write it at all. There's only 1 copy, and then it's just sort of understood it's there. But you can't forget that it's there. We are saying there's a copy of it. All right. Let's go on and do some practice problems. So let's look at this compound. All right, what's in it? Well, I'm saying there's 1 aluminum atom, there's 3 carbon atoms, there's 3 nitrogen atoms, right? The subscript outside the parentheses applies to both C and N. That gives me a total of 7 atoms in 1 copy of this compound. If I'm looking at this next compound, oh, notice, look, it's got that coefficient of 5. The 5 applies to everything. And then I've got the magnesiums, and I've got chromiums, and I've got oxygens. So I have a total of 5 magnesium atoms. I've got 20 chromium atoms. 2 times 2 is 4, times 5 is 20 for the chromiums. And then for the oxygens, I've got 2 times 7 is 14 oxygens, times 5 gives me 70 oxygen atoms, for a total of 95 atoms altogether. Now, another variation on this is we can use it to interpret particle level diagrams. So, here's a bunch of particles, okay? The black circles are carbon atoms, the red circles are oxygen atoms, the yellow circles are hydrogen atoms, and the blue circles are nitrogen atoms. So if we look at those top 3 molecules, right, there are 3 of them that are identical. All right, each one of them has 3 carbon atoms and 4 hydrogen atoms. So I could write it as 3C3H4. If I look at the next set of molecules, all right, they've each got 2 blue atoms and 1 red atom. So 2 nitrogens and 1 oxygen. And there's 2 copies of that. So I'm going to write 2 N2O. And then down at the bottom, I've got 1 lonely little molecule with 1 nitrogen atom and 3 hydrogen atoms. That's NH3. Okay, so in summary, we use subscripts to indicate the number of each type of atom in a chemical formula. We can use parentheses to show multiple copies of a set of atoms within a formula. We can use coefficients in front of the formula to indicate multiple copies of that formula. If you found this video helpful, subscribe to my channel and leave a comment. I hope you found it helpful, and I'll talk to you again.